Hello, everyone. This is Dr. Zach. I'm so glad that you're here to integrate the natural log and exponential functions. So let's get started. For today's lesson preview, you were reminded that the antiderivative of 1 over x is the natural log of the absolute value of x plus c. Now, I want you to always think about your domain restrictions. In this problem, there is no difficulty integrating because you do not have endpoints. However, if I were to integrate from -4 to 4 of 1 over x dx, we would definitely have a domain restriction because your x value under this interval could equal 0, and that would be a problem. For our next problem, you are asked to find the area. Remember to always write an equation for the area. Do not assume that it does not need to be written. The equation should be written as an integral. Use your endpoints. Since we're integrating from 0 to the line x equals 3, we'll go from 0 to 3 and dx. If things went well, you let u equal your x squared plus 1, and then you simplified your problem. Eventually, you should come up with 1/2 natural log of 10. Now, if you wrote an absolute value of 10, that's fine, but simplify the function before you've completed the problem. All right, so our first example, number 1. Notice that you have a number over a function with a variable. So we're going to let u equal the 1 minus 3x. Because remember, the whole purpose of our u substitution is to take complex problems and write them as one of the 8 different integrals that you know. If it doesn't match one of the integrals that you're familiar with, then you need to do something to rewrite our problem. So once we do our substitution with the antiderivative 1 over u du, notice that we have a du over -3. So I'm going to factor out that -1/3. We're left with -1/3 natural log absolute value of u plus c. Now, of course, your problem is not complete unless you fill in your u value as the absolute value of 1 minus 3x plus c, because you want to be infinitely correct. For our next problem, what I need you to recall is that the derivative with respect to x of e to the u is e to the u times du. All right, so now when we look at our problem, this should help us out. The antiderivative of e to the u du will also be e to the u plus c. Knowing that helps you determine that the exponent should be the u value. U equals 3 plus 2x. So du, 2dx, solve for dx, do some fabulous substitutions, and we are on our way to solve this problem. So we have e to the u times 1/2 du. The antiderivative, of course, is going to be 1/2 e to the u plus c. Replace the u value. Don't forget that step, please. So we have 3 plus 2x over 2 plus c. Now remember, you can always check your answer by finding the derivative. And if you come back to where you started, you are on target for integrating correctly. Okay, so looking at example 3, what I'd like you to notice is that the denominator is 1 degree higher than your numerator, which leads me to believe that if we let u equal x cubed plus 1 and find the derivative, we're going to be nicely set up for a natural log as the antiderivative. So once we look at the substitution, you can change your x's. Remember, these are x values for this definite integral. You could change them though, make it 2 to 65. You're going to be left with x squared plus 1 in the numerator, which is not going to work out to make them cancel. So let's do something a little tricky. We're going to write this as x squared, x cubed plus 1, plus the antiderivative from 2 to 65 of our 1 over x cubed plus 1 dx. Now when we substitute, we're going to have, oh, don't forget dx here, we will have 1/3 2 to 65, 1 over u du, plus, now this next piece didn't come out as nicely, did it? Because when you substitute, you're going to be left with 1 over 3x squared times 1 over u du. So you're mixing your x squareds and your u's together. So let's imagine for a minute you're in the middle of a test and you just don't know how to deal with the problem. And that's why I chose this one. You don't know how to integrate 1 over x cubed plus 1 yet. What you should do is demonstrate knowledge. And when you demonstrate knowledge, you're going to have the natural log of 65 minus your natural log of 2. But then this next piece, you just don't know the answer. So go back, put in your x's, just put everything back the way it was. Here's your x cubed plus 1 dx. Admit that you don't know the answer to the second part of the problem and be done with it. Don't spend your time on something that you do not know. So now I'd like you to practice questions 1, 2, and 3. Turn the video off, practice the problems, and then come back. Number 2, pretty straightforward. Let u equal the tangent of x, and you will be set. Number 3, let's take a look. If you rewrite the problem as sine over cosine, let u equal cosine, du is negative sine, change some endpoints, do your substitution, you should be fine. Oh, wait a minute. Did you notice that there is a domain restriction and that your x's cannot be pi over 2, 3 pi over 2, etc. So this problem is actually no solution. Remember, keep an eye on your domain restrictions. So for example 5, I wanted to remind you about initial value problems. We're going to let dy equal e to the 3x over e to the 3x plus 1. So we're going to, once again, separate the variables. And now using those separation of variables, we are permitted to integrate both sides, in which case we get y equals, now let's look. If I were to let u equal e to the 3x plus 1, du would be 3e to the 3x dx, in which case I can substitute and simplify my problem. And I will now have the integral of 1 over 3u du. And we know that that would be 1/3 the natural log of the absolute value of e to the 3x plus 1 plus another c. Now that we know our function, we can use y at 0 is equal to 5 to find the c value. So 5 equals your 1/3 natural log of the absolute value, e to the 0, which is 1, plus 1 is 2, plus c. We don't need that absolute value since 2 is positive. So c equals 5 minus 1/3 the natural log of 2. Finally, we write our answer. The particular solution is going to be 1/3 natural log absolute value e to the 3x plus 1 plus our 5 minus 1/3 natural log of 2. Now the absolute values in these problems are not necessary because e to the 3x plus 1 is always positive. Now, as we take a look at questions 4 through 10, give these a try. Stop the video, try the problems, and then come back and check through some of your answers. As you can see, sometimes you have to worry about the negative signs when you're dealing with du. And for question number 6, there was a factor of 3 that you need to take into consideration. So we have a couple of reminders as you work on question 7. Write the formula for your area Not everything is U substitution. So number 7 was not a U substitution problem. You should always sketch a graph. I want you to understand that area is f of x, which is the height, multiplied by your delta x. Those are important details as we go further in our studies. Number 8, u equals negative x to the 4th. Number 9, just substitution again, u equals e to the x plus 1. Number 10, when you do your u substitution, you had a negative, and if you chose to rewrite your problem using u's as endpoints, you could rearrange the endpoints and change the sign, just as a reminder. So as you are working on number 11, you use separation of variables again. Solved for the left side, you got y, and when you did the right side, you got negative 4e to the negative x over 2 plus c. But once again, you had to figure out the c value, given that x was 0 and y was 1. Now for the second part of the problem, if you actually graphed the starting point 0, 1, you would get the purple graph, and if you just used the point that was given to you, you would get the red graph. All right, we have a nice set of problems for you to work on today, and make certain that you do the pages as asked for. Don't work for more than 45 to 60 minutes on this assignment, please.